good afternoon. So today we're gonna talk about volcano hazards. But first, let us have a simple recap about volcano eruption. So when do volcanoes erupt? When molten rock called magma rises to the surface or to the magma chamber, volcanoes erupt, which releases lava. And this magma is formed when the Earth's mantle melts. So how can we tell when a volcano will erupt? Before an eruption, most volcanoes have warnings. According to the Philippine Institute of Volcanology and Seismology, a government service institute responsible for preventing hazards that may result from volcanic eruptions, earthquakes, tsunamis, and other associated geotectonic phenomena, stated that these are the common signs of an impending volcano. The following are the 10 common signs of an impending volcano. First, there is an increase in the frequency of volcanic quakes or rumbling sounds and intensity of felt earthquakes. Second, there is a noticeable small changes in heat flow. Third, there is an increased steaming activity. And there is also increase in temperature of hot springs, wells, crater, lake near the vicinity of the volcano. Then, springs and wells dry up around the volcano. There is also an occurrence of landslides and rockfalls from the summit area. Drying up of vegetation along the upper slopes of the volcano also occurs. And the presence of magma in or near the crater, which causes the crater to shine. And subtle swelling of the ground surface, also called inflation, ground tilt, and ground fissuring due to magma intrusion. And last, as there is a change in the chemical content of springs and craters, lakes, and the volcano's vicinity. So now we're gonna talk about volcano hazards. Every type of volcano, whether during an eruption or a time of silence, is capable of generating harmful events which we call hazards. However, it depends on the type of volcano and eruption on how different volcano hazards occur. Volcano hazards refer to the occurrence of harmful events due to the eruption which risks damage to human life, livelihoods, and/or infrastructures.
Now we will discuss volcanic gases. Volcanic gases are volatile substances released from a volcano or volcanically active area. Volcanic gases are always involved in volcanic eruptions, but they are given off by dormant volcanoes as well. Volatile substances are chemical elements or compounds dissolved in magma that form a gas at relatively low pressure and temperature. So basically, volcanic gases are always present during an eruption or even in the silent times of a volcano. So how are these gases released into the atmosphere? Gases are dissolved in magma. Because this melted rock is less dense than the rock surrounding it, it rises up towards the Earth's surface. As it does, the dissolved gases within the magma begin to form bubbles, which increase the volume of the mixture and make the magma even less dense. As the magma continues its journey towards the Earth's surface, the volume and pressure continue to build and can lead to volcanic eruption, which sends volcanic gases miles high into the Earth's atmosphere. This is the summary of what happens during volcanic eruption. The eruption happens due to the expansion of gases in the magma. These gases come from gaseous substances and other compounds that release gas when heated. One example is water. As the magma rises, the gases expand, causing explosive eruptions. During eruption, the gases are forced out of the vent of the volcano along with other substances. Volcanic gases can also be released at the atmosphere even when the magma does not reach the Earth's surface. This happens because some gases leak from the soil and the volcanic vents, so no eruption is needed. Now let us move to the composition of volcanic gases. Here we have water vapor or steam, which comprises about 78%. We have carbon dioxide that is about 12%, sulfur dioxide which is about 7%, and other gases like hydrochloric acid, hydrogen fluoride, hydrogen sulfide, carbon monoxide, hydrogen gas, and methane. It is about 3%. These gases are produced mainly because of the combination of hydrogen and water. Some of these gases are transported away from the eruption on ash particle, while others form salt and aerosols. Volcanic gases are also produced when water is heated by magma. Gases also escape from pyroclastic flows, lahar, and lava flows, and may also be produced from burning vegetation. This slide shows the harmful effects of the volcanic gases. First example is the carbon dioxide. It is a colorless and odorless gas. Cold carbon dioxide gas is heavier than air, so it can flow in the low-lying areas where it can reach much higher concentration in certain very stable atmospheric conditions. Breathing air with more than 3% of carbon dioxide can quickly lead to headaches, dizziness, increased heart rate, and difficulty in breathing. Inhalation of about 15% of carbon dioxide quickly causes unconsciousness and even death. Sulfur dioxide. It is a colorless gas. It irritates skin and tissues and mucous membranes of the eyes, nose, and throat. It can cause acid rain and air pollution downwind of a volcano. Inhalation of high concentration can be harmful to upper respiratory tract and bronchi. They also have a role in the ozone depletion. The next one is hydrogen sulfide. It is a colorless and flammable gas. It causes irritation to the upper respiratory tract and during long exposure could cause pulmonary edema. Exposure to high concentration can cause a human to fall unconscious in 5 minutes and die in an hour or less. Hydrogen fluoride. It attaches to fine ashes which could coat the grass and can be ingested by animals. Too much intake of this gas could result to fluorolysis, which is a disease that damages the bone. It could also cause conjunctivitis and skin irritation. Volcanic gases does not only affect animals and humans. It also affects agriculture, environment, and infrastructure. Here are the other effects of volcanic gases. It can severely damage vegetation. It could cause corrosion of metals. Volcanic gases have a role in the warming of planet, and it could cause ozone depletion. As I said earlier, volcanic gases are composed of carbon dioxide, which is a greenhouse gas. And these gases warm up the earth. Sulfur dioxide transforms in sulfate aerosol, so they could mix in the air. It reacts to the molecules of the air and accelerating ozone depletion. This slide shows the mitigation measures. But first, what are the areas affected by volcanic gases? I said earlier that volcanic gases are denser than air molecule, so they do not spend a lot of time in the atmosphere, especially if they are not ejected very high. Affected areas would be low-lying areas where high concentration of gases could form, and of course, areas that are along the direction of the wind. Usually, areas that are 10 kilometers far are seldomly affected, but this could change depending on the amount of materials and the power during eruption. This is the mitigation measures. Drink fluids to encourage loosening of secretion and coughing. Staying hydrated will help clear the particles and inhaled sulfur compounds from the lungs. During periods of volcanic eruption, avoid contact with people who have colds. Avoid smoking and inhaling secondhand smoke, and this will only add to breathing problems. Avoid overexertion. If one has to go, limit physical activities. In heavy pollution, stay indoor. Close window and doors and turn on air conditioner and purifier. Now let us move to tephra and ballistic projectiles. Tephra refers to all volcanic rocks and lava materials that are ejected into air by explosion or carried upward by the eruption of hot gases and lava fountains. Tephra are the materials that do not move downward along the slope of the volcano, but these are the materials that are ejected in the air. Large tephra tend to fall back to the ground close to the volcano. Smaller tephra are carried by the wind. Tephra are one of the least dangerous but troublesome because of how far they travel. Ballistic projectile is the special kind of tephra. This consists of bombs, blocks, and lapilli. These are ejected at an angle of greater than 45 degrees or follows a projectile path. It is rare that these materials travel beyond 5 kilometers. Now these are the types of tephra and ballistic projectiles. They are classified through their sizes, origin, and composition. The first one is ash. It is the smallest type. It is less than 2 mm in diameter. It could circle around the globe if the eruption is strong enough. It usually makes up a tephra. The second one is lapilli. The size ranges from 2 to 64 mm in diameter. This could be pumice or scoria falls. Pumice is when vigorous amount of gas is released and when lava is rich in silica. Scoria is when lava or magma is poor in silica content. The last one is the blocks and bombs. These one are the largest. They are greater than 64 mm in diameter. Bombs are from fresh magma and blocks are from chips of walls of the volcanic vent. Volcanologists classify them according to their sizes because the larger ones would be near the volcano and the smallest one would be farther away. This slide shows the dangers of tephra and the ballistic projectiles. They are airborne fine particles with conjunctivitis and corneal abrasions, meaning to say, they could cause serious respiratory diseases such as scarring of lungs. Ash could accumulate on roofs, which could cause the roof to collapse. It can break power and communication lines. It could destruct the agricultural lands. It can damage metals and woods, thus damaging houses and infrastructure. It could cause zero visibility and may clog in air filters and vents of factories and automobiles. It can change rainfall and runoff, which might accelerate erosion and floods. It contains various chemicals, toxic gases, and acids. Now this is how we mitigate the effects before, during, and after the tephra falls. Before tephra falls, protective clothing and high-efficiency dust mask should be available and placed in easily accessible areas. Design roof orientations and pitch to discourage thick tephra buildup. Strengthen roof and wall to withstand loading and projectile during tephra falls. Wear protective clothing and high-efficiency mask. If no mask is available, We could improvise a fabric mask that is made up of damp handkerchief or any clothing. Those who have respiratory illnesses are advised to stay indoors. Keep all doors closed when there is a heavy accumulation of ash. When driving, keep proper distance to other vehicles. Clear tephra from roof as it accumulates. After tephra falls, remove or stabilize tephra on ground after the fall. Handle ash in an open, well-ventilated areas and wet dust whenever possible to prevent its movement. Wear goggles instead of contact lens to protect eyes from irritation. Persons that are not essential for emergency should stay indoors.
Lava flow is an outpouring of lava created during an effusive eruption. Explosive eruptions produce a mixture of volcanic ash and other fragments called tephra, rather than lava flows. Although lava can up to 100,000 times more viscous than water, lava can flow great distances before cooling and solidifying because lava, exposed to air, quickly develops a solid crust. This insulates the remaining liquid lava and helping it keep hot and invisible. There are three basic types of lava flow, namely number 1, the Pahoho lava flow, number 2, the AA lava flow, and the number 3, the pillow lava flow. So the first one, which is the Pahoho lava flow. Pahoho is a smooth and continuous lava crust. Pahoho forms when the effusion rate is low and consequently the velocity of lava flow is slow. Pahoho lava flow is usually at least 10 times slower than the typical AA lava flow. The second basic type of lava flow is the AA lava flow. AA lava flow is a type of lava flow that is thicker, has high viscosity, and moves very slowly. It has a very ridged surface. Once it hardens, it forms a sharp, shiny surface on the slope. The third basic type of lava flow is the pillow lava flow. Pillow lava flow usually basaltic or andesitic in composition and always associated with water. Pillow are about 1 meter across each or smaller and form when lava flows out of the Earth's crust underwater. Each pillow is like a bag that has quickly chilled margin, which is filled with molten material. Pillow lavas are usually associated with mid-ocean ridge volcanism. The upper part of the oceanic crust is composed of countless number of lava pillows, but they can also form in much shallower conditions, even in lakes or under glacial ice. Pyroclastic flow is a dense, fast-moving flow of solidified lava pieces, volcanic ash, and hot gases. It occurs as a part of a certain volcanic eruptions. A pyroclastic flow is extremely hot, burning anything in its path. It may move up at speeds as high as 200 meters per second. During the day, they appear to be gray and ashy, while at night they appear glowing red hot. It flows normally 5 to 10 kilometers away from the volcano summit, but in the biggest eruptions, it may reach up to 20 kilometers. Pyroclastic flows form in various ways. A common cause is when the column of lava, ash, and gases expelled from a volcano during an eruption loses its upward momentum and falls back to the ground. Another cause is when volcanic material expelled during an eruption immediately begins moving down the sides of the volcano. Pyroclastic flows can also form when a lava dome or lava flow becomes too steep and collapses. In general, there are two end-member types of pyroclastic flows, namely the Nuit Ardentes and the Pumice flows. So the Nuit Ardentes, a French geologist, Alfred Lacroix, attached the name Nuit Ardentes or the glowing cloud to the pyroclastic pyroclastic flow from Mount Pili that destroyed the city of St. Pierre at 1902. The flow was generated from the explosive collapse of a growing lava dome at the summit of the volcano, which then swept down on the city. The second one is the pumice flows. Pumice flows are pumice-rich pyroclastic flows derived from the collapse of an eruption column. The lowermost part of the eruption column is called the gas thrust region. Here, the density of the eruption column is greater than the density of the surrounding air. The column continues to rise, however, because of the thrust provided by the release and rapid expansion of volcanic gas. Occasionally, the gas thrust region may become so chock full of debris that its high density cannot be supported by the thrust and expanding gases. The column thus collapses downward under gravity as a mass of vesiculating pumice that advances rapidly down the flanks of the volcano.
Lahars. Lahars are violent type of mud flow or debris flow composed of pyroclastic materials, rocky debris, ice, woods, and water that originate from volcanoes. They can occur with or without an eruption. Lahars vary in size and speed. Small lahars, less than a few meters wide and several centimeters deep, may flow a few meters per second. Large lahars, hundreds of meters wide and tens of meters deep, can flow several tens of meters per second. Lahars of sufficient size and intensity can erase virtually any structure in its path and is capable of carving its own pathway, making the prediction of its course difficult. Since lahar flows in great distances, nearby residences are still in danger. Lahars and excess sediments causes serious economic and environmental damage to rivers, to river valleys, and floodplains. Lahar forms in various ways. Small slope collapsing into a water reserve on their way down a volcano, rapid melting of ice and snow during an eruption, heavy rainfall, volcanic erupting through a crater lake, and overflowing of water in the crater lake. Ashfalls. Ashfalls, or volcanic ash, consists of fragments of pulverized rocks, minerals, and volcanic glass measuring less than 2 millimeters. It is formed during explosive volcanic eruption, when dissolved gases in magma expand and escape violently into the atmosphere. The shear forces of the gases shatters the magma and propels it into the atmosphere, where it solidifies into fragments of volcanic rock and glass. Ash is also produced when a magma comes in contact with water. During pretomagmatic eruptions, causing water to explosively flash into stream, leading to shattering of magma. Once in the air, ash is transported by the wind thousands of kilometers away. Due to its wide dispersal, ash can have a number of impacts in society, including animal and human health, disruption of aviation, disruption to critical infrastructures, telecommunications, water, and waterways network, primary industries, buildings, and structures.